Welcome to the Chapter 8, Part 3 video. We will be reviewing how to add fractions and looking at the least common multiple, which is the least common denominator, but not necessarily as a denominator. Looking at adding and subtracting rational expressions, and then finally closing out with complex fractions. So first, let's review the least common multiple, which means the least common denominator, but it doesn't have to be a denominator. So if I'm looking for the least common multiple of these two expressions here, what I want to do is factor until I can't factor anymore, and then create a new expression that contains all of those factors. So I'm going to say 12 is 4 times 3, and 4 is 2 times 2. So I can write that as 2 squared times 3 times x squared times y. And then I can also factor this. Two numbers that multiply to 1 and add to 2 are 1 and 1. So that's x plus 1 squared, or x plus 1 times x plus 1. And then the second expression, and I'm actually going to do it in a different color here. I'm going to do the same thing. 9 times 2, 9 is 3 times 3. So I have 2 times 3 squared. I'm putting them in ascending order, therefore it'll be a little bit easier for me to see all the factors. X, y cubed, two numbers that multiply to 4 and add to 5 are 4 and 1. So that's x plus 1 times x plus 4. Now I want to create a new expression that contains all of those factors. So I need 2, but I need 2 squared. I need 3, but I need 3 squared because there's 2 factors here in the second expression, the blue one. Then I need x squared. So I'm taking the highest power of each of these factors, y cubed, x plus 1 squared, and x plus 4. Now I've underlined them to make sure that I've included everything. So I can tell that this will be the least common multiple because I've included each of the factors. Everything is underlined. And that means I should be able to divide the one that's in black by each of the ones in red and blue and have no partial remainders. It should divide evenly in. Okay, so let's try 2 more examples here. Part A, I'm looking for the LCM of 2x plus 4 and x squared minus x minus 6. Factoring, this is 2 times x plus 2. And this one, I need 2 numbers that multiply to -6 and add to -1. That's going to be -3 and 2. That leaves x minus 3 and x plus 2. So I have 2, I have x plus 2, and I have x minus 3. And all of those were to the first power. So there is my least common multiple. Okay, for part B, I'm doing the same thing, but this time I have 3 expressions that I'm trying to find the least common multiple of. Same process, we're just going to do it with 3 expressions. X squared plus 3x minus 4, x squared plus 2x minus 8, x squared minus 4x plus 4. Okay, so this factors, I need 2 numbers multiply to -4 and add to 3, so that's going to be 4 and -1, x plus 4, x minus 1. 2 numbers that multiply to -8 and add to 2, that's going to be 4 and -2, x plus 4, x minus 2. And then 2 numbers that multiply to 4 and add to -4, that's going to be -2 and -2, x minus 2 squared. Okay, so now my LCM, I need a factor of x plus 4. I need a factor of x minus 1. I need a factor of x minus 2, but I actually need that to be squared. And then everything is underlined, so that means I've included everything already. There is my least common multiple. Okay, so that's the process that we're going to use in order to add and subtract rational expressions. To add rational expressions, the first step is going to be to factor everything. Okay, so I'm looking at this expression here. I'm adding 2 fractions. The first fraction is already factored. The second fraction, to factor this denominator, I need 2 numbers that multiply to 2 and add to -3. That's going to be -2 and -1. So this denominator factors into x minus 2 times x minus 1. That means my LCD, I can use least common denominator here because these are denominators, is going to be x minus 1 times x minus 2. Now, in order to get my first fraction to have that denominator, I need to multiply that fraction by x minus 2 over x minus 2. So when I multiply that, I get x times x minus 2 divided by x minus 1 times x minus 2. That's my first fraction. The second fraction already has my least common denominator, so I don't need to change that. Divided by x minus 1 times x minus 2. Now that they have the same denominator, I can add the numerators. Same denominator, so I can add the numerators. I'm going to go ahead and distribute. So that's x squared minus 2x is my first numerator, plus 2x minus 2 is my second numerator. Notice I put them in parentheses. That's so that I don't accidentally drop a negative or forget to distribute. For addition, it is not as crucial, but since it will be crucial for subtraction, it's a good habit to just always do it. Okay, now I'm going to distribute. Here I'm distributing a positive 1, so that's not going to change the values. So this becomes x squared minus 2x plus 2x minus 2 all over x minus 1 times x minus 2. Combining like terms, those two middle terms actually cancel out. So we get x squared minus 2 divided by x minus 1 times x minus 2. Actually, if you look up in my second step, I copied that 1 as a 2. So everywhere that had an x minus 2, that should have been a 1. Because of here, it's a 1. 1. This one should be a 1. 1, 1. Okay, that was a typo. I copied the number incorrectly. Okay, now we're going to see, can we factor the numerator? The numerator does indeed factor. It's a difference of perfect squares. So that's x plus 1 times x minus 1 divided by x minus 1 times x minus 2. Simplifying this fraction, I can reduce by x minus 1. So our final answer here is x plus 1 over x minus 2. I do have restrictions. I have denominators, and those restrictions will always come from the LCD, as well as any other denominators I had along the way. So for addition, there's no other denominators along the way. Everything that is in the denominator, every factor in the denominator was in the LCD. So that tells me x cannot be 1 and x cannot be 2. X cannot be 1 and x cannot be 2. We can also see that from this denominator here, x cannot be 1 and x cannot be 2. Okay, I have two examples for you to try. So go ahead and try these and then we'll look at them together. All right, looking at just part A, we need to factor the second denominator, then we can get our LCD. We need to multiply the first fraction by x over x in order for both fractions to have the same denominator. Once they have the same denominator, we can add the numerators. I simplified while I combined them, so I did kind of 1.5 steps at the same time. And then combining like terms, in this case, there were no like terms to combine, so then we factor, simplify, and then write our restrictions. Okay, if you haven't already, go ahead and try part B. All right, for this one, again, we factor. This time it's the first denominator that we have to factor. So we factor the first denominator, find our least common denominator. In order to get our least common denominator, we need to multiply the second fraction by x minus 2 over x minus 2. Once we do that, we have the same denominator, so we can add across the numerators, combining like terms and factoring. This time we can't simplify, so that is our final answer, and we just need to find our restrictions, which are positive and negative 2. Go ahead and pause the screen if you need more time to look at this problem. Next, we're going to look at subtracting rational expressions, and the process is exactly the same, except this time we're going to have a negative that we'll need to distribute. So same process, we're going to start by factoring. The first denominator factors x times x minus 2. Second denominator factors 2 times x minus 2. That makes our LCD x times 2. I'm going to write it as 2x times x minus 2. That means our first fraction needs to be multiplied. It's missing the 2, so that needs to be multiplied by 2 over 2. Our second fraction is missing the x, so that needs to be multiplied by x over x. Once we multiply, now we have 2 times x plus 2 in the first numerator times 2x times x minus 2 in the first denominator minus x times x plus 2 in the second numerator divided by 2x times x minus 2 in the second denominator. My denominators match, so now I can subtract. I'm going to go ahead and distribute while I subtract. So that's 2x plus 4 in my first numerator minus x squared plus 2x in my second numerator, all divided by 2x times x minus 2. Notice this time I do indeed have to distribute that negative. So we have 2x plus 4 minus x squared minus 2x all over 2x times x minus 2. Simplifying like terms, the 2x minus 2x becomes 0. And I'm going to go ahead and write this in descending order. That's negative x squared plus 4 over 2x times x minus 2. Starting in the next column here, I'm going to factor the numerator. That's a negative 1 that I can factor out, leaving me x squared minus 4 divided by 2x times x minus 2. Now my numerator still has a difference of squares, so I can write that as x plus 2 times x minus 2. Don't forget the negative coefficient that's still there. 2x times x minus 2. Everything is factored, so now I can reduce, leaving me with negative quantity of x plus 2 divided by 2x. That x plus 2 needs to stay in parentheses unless you're distributing the negative. If you don't want those parentheses, you could write it negative x minus 2. I do not recommend this, divided by 2x. I would recommend writing it this way. And then I have to look at my restrictions. Now, x cannot be 0 because 2x is 0 when x is 0. So x cannot be 0. And then my second factor here, x cannot be 2. So I have two restrictions, x cannot be 0 or 2. Okay, again, I have two examples here for you to try. So go ahead and try these, and then we'll look at the solutions together. All right, for part A, factor the second denominator, we find our LCD. I need to multiply the first one by x minus 1 over x minus 1. Once we have the denominators matching, we can combine the numerators. I went ahead and FOILed that first numerator so that it would be easier to simplify. Distribute the negative, combine like terms, factor again, I can simplify. I have my final reduced form. Okay, the restrictions come from the denominators. So the numerator x minus 2 is not giving me any restrictions. It's because of that x minus 2 that got canceled out that we have a restriction of x equals 2. Part B, go ahead and try if you haven't already. For part B, same process, factor the second denominator, find the LCD, multiply the first one by x plus 1, which is the missing factor from the denominator. Once we have the denominators matching, we can add the numerators, or in this case, subtract the numerators. I went ahead and FOILed the first numerator and combined like terms. It's a difference of perfect squares there. If you recognize that pattern, distribute the negative, combine like terms. This time it's not factorable. The numerator is not factorable, so I can't reduce, giving me just the restrictions from the denominator -1 and -5. Go ahead and pause if you need more time to look at this screen. Our last example here is complex fractions. Complex fractions means a fraction within a fraction. And the process for this is that this symbol divides by, we're going to actually write it as a division. So we have the numerator divided by the denominator. It's very important to use parentheses here. We have 1 over x plus x over y in parentheses divided by 1 over y plus 1 also in parentheses. We're going to look at this as two addition problems and then the division problem. So I need an LCD for my first pair of terms is xy. So I need to multiply the first term by y over y and the second term by x over x. That gives me y over xy plus x squared over xy. Combining the numerators, that's y plus x squared over xy. That is divided by my second term, or my second pair of terms. That LCD is y, and then the second denominator is 1. So I don't need anything in my LCD because y times 1 is just y. That means I need to multiply my second term by y over y, giving me 1 over y plus y over y, or 1 plus y over y. From here, it's what we saw in section 2. We're going to do the keep, change, flip, or multiply by the reciprocal. So my first term stays the same, y plus x squared over xy. This turns into multiplication of y over 1 plus y. Because this is multiplication now, I can write it as a single fraction. That's y plus x squared times y divided by xy times 1 plus y. Nothing else can be factored, so that is my answer. Okay, that is it for this section. The only thing left is the practice problems. There are 4 practice problems here for you to try.